Okay, here we go. All right, solving by substitution. So here's the system. Remember, a system of two equations is what we're going to work with right now. So we want to find the solution. So I want to find the x and the y that work for this system. And this is the method we're going to use. Okay, so then I'm going to do some steps over here. Step 1. Get one variable by itself. So you can pick one equation and get one variable completely by itself. Now in this case, do you see a variable already by itself? Yeah, the y. This one is already by itself. So that first step is done for us in this case. Okay, it won't always be like that, but the first few we do will be like that, so you don't have to do too much. Okay, after the variable is by itself, bless you, we're going to substitute the quantity, and that just means the y equals something. Whatever that something is, we're going to substitute that into the other equation. So substitute the quantity into the other equation. So if y equals this, I'm just going to circle this whole thing. It doesn't matter what it is. It could be a single number. It could be a huge thing. This is just two different terms. And I'm going to substitute into the other equation into this y. So we're going to write that out. So I have 4x minus 3. Okay, so that's from the original equation. But then, instead of putting a y, I'm going to put what y equals, which is 2x plus 3 equals 1. So same exact equation, but in for the y, I put 2x plus 3. So step 3, I want to solve for the remaining variable. So in this case, we're going to solve for x. Okay, so over here, you've done this before. So I'm going to distribute. So I have 4x minus 6x minus 9 equals 1. So combine line terms. Negative 2x minus 9 equals 1. Add over the 9. So negative 2x equals 10. How do I solve for x? Divide by negative 2. Divide by negative 2. So x equals negative 5. So since we're doing a system, I want to solve for x and y. So then the last step over here, substitute the variable sorry, this was a long one. Substitute the variable back into one of the original equations. So I'm going to take this x equals 5 right here, and I'm going to put it into that first equation, y equals 2x plus 3. It doesn't matter which one you put it in, either the first one or the second one. But now we know what x equals. So put negative 5 in. So negative 10 plus 3 this one is not bad. The one tomorrow I think is a little bit easier, only because I think it's a little shorter, but requires a little more thinking. But it's less work, so some people like that one more. Does everyone have that one? Okay. All right, so I have 6 examples for you, so just stick with me. Some of them are short because some of them have special answers. So first one. So on your test, which is not till next Friday, it'll say solve by substitution, solve by elimination. So make sure you know which one is which. This is substitution. I have seen people mix up the two. So substitution, I am substituting a whole equation into the other one. Tomorrow's elimination, you'll be able to tell the difference once we do tomorrow. Okay, so the first step, I need to get a variable by itself, and they already gave you this one. So this is very similar to the one we did. So I'm going to take this whole thing, 2x minus 1, put it into the y. Why do I put it in the y and not the x? Because it's y equals. Okay, we're going to do one in a little while that's x equals, so we'll go into the other one. That way you can see both. All right, so let's substitute that in. 3x plus 2. And then instead of y, I'm going to put 2x minus 1 equals 26. So go ahead and solve for x. Plug it back in and then see if you can get the y. This is just your basic algebra. Most of you guys are really good at this. The worst part of this is if you get the first one wrong, it means the second one's usually going to be wrong. So there's x equals 4. And then I'll just go over here. Again, you can go back into either one of them. I'm going to go back into the first one. Like, I forgot where any of this now. Remember that open note quiz on Monday? You're not going to have anything about substitution in there? Okay, I'm just saying. I'm not going to answer questions if you don't even have it written in your notes. How do we do? Good? Not too bad? So again, you could get this by graphing, or substitution, or elimination. This is just one method. It will say, solve the system by substitution. So substitution, you have to know I'm going to take an equation, I'm going to substitute it into the other one, and then solve for x and y. Tomorrow we'll say solve by elimination, and you'll see the difference tomorrow. Okay, so number 2, 3x plus y equals 7. 4x plus 2y equals 6. So we don't have a variable by itself. You can pick the x or the y. The easiest to pick though is if you already have, like this y is already a positive 1y, so I want to get that y by itself. You could pick the x, you could pick the second x, or the second y, it doesn't matter. I'm going to pick this first one because I can't do any substituting until I have a variable by itself. So 3x plus y equals 7. How do I solve for y? Minus the 3x. So y equals negative 3x plus 7. So now that I have y by itself, I take this whole thing, negative 3x plus 7, and I put it into the second equation. So same thing, but one step further, we have to get the y by itself. So 4x plus 2 times negative 3x plus 7 equals 16. Remember, at the end, you can always go back and check your answer. If you're unsure, you plug both answers in like we did on Monday, I think we did that. Did we get negative 1 for x? Okay. Now, it says in the steps, go back to one of the originals, so you can go back and put the x in here or here. I sometimes do shortcut and I go to this that I already found y for. It doesn't matter though, but I'm going to go back to this one. It just saves you a tiny bit of time. But you can really plug it in anywhere, one of the originals or this one right here. So what is that? 3 plus 7 is 10. So negative 1, comma. All right, ready for number 3? Like.
So, like, when they give us 2 things, you want us to just put the one in y equals supposed to be 1, like on top?
Yes. However, like the one, well, on number 4, I'll show you. You can always solve for y if you want to, but you can sometimes solve for the x. Like if this was switched and it was like x plus 3y equals 7, it would be easier for, oh, you can see that. X plus 3, it would be easier for me to do the x by itself. So I would subtract 3y over, so it would be x equals negative 3y plus 7. But if you're uncomfortable with that, you can still always get the y by itself. You're just going to end up with a fraction, and so you just have to be really careful with a substitute. But it still works. It's just a little bit uglier. But I'll show you. I have one like that where it's x. Okay, number 3. Okay, what would you do first here? Yeah, so let's take the first equation. So one of my students in first period said, well, how do you know which one is by itself? If you already have something without a number in front, I would go with that one. So I'm going to take this one and get y by itself. So same thing as before, subtract the 2x. So y equals negative 2x plus 8. So I'm going to put negative 2x plus 8 into this y. Okay, so go ahead and solve for x. What happens to the 6x and the 6x on this one? They cancel. So I get 24 equals negative 15. What do you think our answer is here? No solution. What kind of lines would those be? Parallel. Good, I hear it. Parallel. Parallel lines, remember, they never ever touch, so there's no solution. Do you remember what it's called? Inconsistent. Good. Now, you don't have to write that. I'm just reviewing with you what those words are. Nope. As soon as you get that. Okay, number 4. So here's the one where I'm going to solve for the x on this one so you can see what it looks like. You are welcome to solve for the y. The only problem is you just get those icky fractions. So when I look at this and I'm trying to figure out what I want to solve for, I see that x already by itself, so that's the one I'm going to solve for. You solve for the x the exact same way you would solve for the y. It's just unfamiliar to you because we haven't done that before. So I'm going to subtract 4y over. So x equals negative 4y minus 4. So where do I put this in? What do I do with that? Right, put in the other x. I'm going to do a big arrow up here. It goes into the x. So be careful that I have seen people before put it into the y because you just get confused. Remember, if you solve for x, it goes into the x. So I'm on the first equation now. I have 3 times negative 4y minus 4 plus 5y equals 2. Negative 12y minus 12. So when you're doing these, just be really cautious of your algebra here, your adding, subtracting, because that will definitely messes your answers up. So y should equal -2. Yeah. And then, again, you can go back to one of the originals. Or if you want to do a little shortcut, I'm going to go back to this one where I already have x equals -4 times -2 minus 4. So 8 minus 4. Perfect. 4 -2. When you get one solution like this, what kind of lines do you have? Yeah, where they just touch one time. Do you remember what that's called? One solution is, it is consistent. Oh, there we go. Independent. Independent and consistent. Remember, consistent just means yes, there's a solution. Whether it's one or infinite, it's consistent. Yeah, it's only 4 problems. I don't need 4 of these. Okay, I have 2 more for you. And I need paper. Okay, number 5. This is a little bit different just because it's in a different order. Like flip it if you want the wild one. You can, yeah. So I like the y on the left. It doesn't matter though. If you want to leave it on the right, it's okay. So I'm going to take this equation and I'm just going to flip the sides. I'm not flipping signs yet. I'm just switching. So I'm going to put the negative y on the left, and I'm going to put 2x minus 2 on the right. Just because it's what you're used to seeing. But this still has to be a positive y. So how do I get rid of that negative? Perfect. Divide by -1 on everything. So y equals -2x plus 2. And again, you don't have to flip sides. You can leave it. You can leave the y over there and divide whatever works for you. So I take this whole thing and I put it into this y right here. So 5x plus 6 times negative 2x plus 2 equals negative 9. So 5x minus 12x plus 12 equals negative 7x plus 12 equals negative 1. So what do we get for x? That's positive 3. And then go back and plug positive 3 in. So what is that? Negative 6 plus 2, negative 4? So 3, negative 4. Anyone still writing number 5? Okay, last one. Question?
Wouldn't that be negative y?
Oh, right here?
Yeah.
Well, I went to this one where I already got the y by itself,
Okay.
so negative. You could go up here though, so I'm going to positive 2. You should still get the same answer. All right, last one, number 6. 56x plus 8y equals negative 32. And 7x plus y equals negative 4. Okay, so I see this y by itself, so this is the one I want to get by itself. So 7x plus y equals negative 4. Subtract over the 7x. So same thing, put that negative 7x minus 4 into the other y. So 56x minus 56x minus 32 equals minus 32. They do cancel out. These two cancel out. But look at what you're left with. Negative 32 equals negative 32. Yes. And instead of all real numbers, you say infinite solution. Well, I guess it's the same thing. Infinite solutions, all real numbers. What kind of lines are those when you get infinite solutions? The same line. You remember what it's called, what the system's called? Dependent. And then we also say consistent. Dependent, consistent. No, I'm just reviewing. You have to say infinite solutions are all real numbers. I'm just reviewing the words with you. You don't have to say that. No, on